Hi, welcome to a review video for the final. So let's work on problems from the review problems for final sheets. It's 2 pages, okay? And so let's start here in this video with number 5. So for 5a, so for 5 you want to evaluate the area between curves. And so for 5a, we have y equals x plus 1. Y equals 9 minus x squared, x equals -1, and x equals 2. We're going to find the area between curves. So let's draw these curves out. So y equals x plus 1 looks like this. Y equals 9 minus x squared looks like this. It's y equals 9 minus x squared. X equals -1. Well, this point is -1 comma 0. This point is 3 comma 0. This point is -3 comma 0. Right, so just all the curves are. You need to have the curves drawn in relationship to each other. So x equals -1 is going to go through that point. That's x equals -1. Right? So it's important to the relationships between the curves to be depicted in the picture correctly. So x equals 2 is going to go here. Now, what is the intersection point at that point? Right? Does x equal 2 go to the right of that point, to the left of it, or right on that point? Well, to find the intersection point, you set the two y values equal to each other. X plus 1 equals 9 minus x squared. Solve for x. So you have x squared plus x minus 8 equals 0. Moving the x squared to this side, minus 9 on both sides. And see what you get is x is equal to -b plus or minus the square root of b squared minus 4 times a times c over 2 times a. That's equal to -1 plus or minus the square root of 1 plus 32. 1 plus or minus the square root of 32 over 2. And so what that's equal to is -1 plus or minus 4 root 2 over 2. That's equal to -1/2 plus or minus 2 root 2. And so this problem is not as difficult because you're integrating from -1 to 2. But what I'm checking is where x equals 2 is. It should be to the left at this point. And so it's saying the intersection points are at -1 minus 2 root 2 and negative. So the x coordinate of this point, this is when x equals negative, we don't need the y value, when x equals -1/2 minus 2 root 2. And the x value of this point is x equals -1/2 plus 2 root 2. All right, and so all right, and so -1/2 plus 2 root 2 is more than 2. If you put in your calculator, you'll get more than 2. So x equals 2 is to the left of that point. Right? X equals 2 is to the left of that point because x equals -1/2 plus 2 root 2 is more than x equals 2. -1/2 minus 2 root 2 is definitely less than x equals -1. Oh, we already have that here. We have x equals -1. Okay, so we have x equals -1, x equals 2, and so we're finding the area bounded by those 4 curves. And so it's this area here. All right? You might guess that, drawing some of the picture, that this is the upper function, that's the lower function, this is the left x value and the right x. You might guess that they're giving you the least x value and the largest x value as the curve, right? And so I'm just confirming that in the picture. All right? So we have this region here. So you're just solving for the x coordinates of the intersection points, and they're outside of this region, so they don't play any role in this. Right, so just checking. So now let's find the area. The area is the definition from x equals -1 to x equals 2. The upper function, this is the top function. This is the top one, and this is the bottom one. Right? The top one because in the shaded region, this is the graph at the top. It's that. the graph of the bottom one is there, right? So you can't look at where I wrote the equation on the board, right? The equation up here that I wrote the top part of the board is the bottom function, and the equation I wrote down here is the top function. And so I wrote the equations here just because it's outside, it's out of the way of the picture, right? And so the parabola curves down, and so when the parabola leaves the picture, in a sense, it's over here. So I just wrote that. All right. One good thing to do is to label this is top and this is bottom on your picture. And so when you label this is top and this is bottom, you then follow the graph, and then you see that's the top function. When you label this is the bottom, you follow the graph, and you see that's the bottom. Right? This is the top, that's the bottom. So if you write the words top and bottom above and underneath your shade region, you're labeling the graph of the top and bottom function. And so then that leads you to say that's the bottom one, that's the top one. All right, so the area is the top function. Now that I labeled this top and this bottom, after labeling this top and bottom, I then labeled this top and bottom. And so I can just look at this. And so this is the definition from -1 to 2, the leftmost x value of the shade region to the rightmost x value of the shade region of the top function, which is 9 minus x squared, minus the bottom function, which is x plus 1 dx. And so just find that definite integral. And so this is equal to, now I'm going to combine like terms here. And so you get negative x squared, then you get a minus x, you get a minus 1 plus 9 is plus 8 dx. Minus 1 plus 8. And so this is equal to negative x cubed over 3 plus minus x squared over 2 plus 8x, valued from -1 to 2. And so you just plug in a 2 there, you get negative 8/3 minus 4/2, which is minus 2, plus 16, plugging in a 2, minus plugging in -1, you get positive 1/3 minus 1/2 minus 8. And so we add this up and subtract that, you get negative 8/3 minus 1/3 is negative 9/3. That's minus 3 minus 5, 11 minus negative 8, 19, 19.5. It's 19.5. All right, the answer is 19.5 for the area. That's 5A. Right, so this is just a list of problems, right? The file is not structured where, for instance, in 4, there's A through F, right? Where there's lots of questions. That's not the way the file is. This is just a list of problems to study from. Okay, so this is 5B. Y equals x squared. Y squared equals x. Okay, so you have these two graphs here. So you have the y-axis, and you have the x-axis. Okay, so you have y equals x squared, and so y squared equals x looks like this. Okay, so those are the two graphs. They intersect at the origin. They also intersect at this point. And so what is that point? It looks like 1 would work, right? So if everything's 1, 1 equals 1 squared, 1 squared equals 1. So this point is 1 comma 1. Okay? Yeah. Sometimes you can use common numbers like 0 or 1 or -1, or maybe 2, maybe -2. Those numbers sometimes will give you important information if you just guess that it's that. So here I guessed that x and y are 1, and it turns out it satisfies both equations. So 1 comma 1 is an intersection point of two graphs. And so now that's the region between the two curves, and we have the intersection points 0 comma 0 and 1 comma 1. And so the area here is, because instead you could solve for it, you could solve for the intersection point here, but it's much easier just to guess x and y are 1 and get that right. It saves you time. So so A is the definite integral from the leftmost x value, which is 0, to the rightmost x value, which is 1. And then we're going to take the top function minus the bottom function here. So this is the top function. I'm going to label this as the top function and label this as the bottom function, right? So this is the top function because it's at the top of the shade region. I follow the curve. This is the top function here. Okay? This is the bottom function. I follow that. This is the bottom function. Okay? I'm going to circle where you look. So the top function, this is in terms of x. So instead of y squared equals x, I could write this as y equals the square root of x. And here's y equals x squared. So the top function is the top y value, which is x to the 1/2, minus the bottom y value, which is x squared, equal to x squared. All right? We need everything in terms of x because we're differentiating with respect to x. That's because if you draw an approximating rectangle here, the thickness of the width of the rectangle is a change in x values, is a difference in x values. So we're integrating it with respect to x. So I'm just going to write this over here. So I wrote or y equals the square root of x to the 1/2. This is equal to an antiderivative of that, which is 2/3 x to the 3/2 minus 1/3 x cubed. That's an antiderivative of the integrand evaluated from the lower limit to the upper limit of the depth interval 0 to 1. That's by this equal sign is by the evaluation theorem. Okay, and so now this is equal to plugging in 1. You get 2/3 minus 1/3 minus 0. Right, so you don't need to minus 0. 2/3 minus 1/3 is 1/3, and so the final answer is 1/3. So that's 5b. Okay, so number 6. Number 6 is find the volume obtained by rotating the region bounded by the given curves about the specified line. Sketch the region, the solid, and a typical disc or washer or cylindrical shell. Okay, so 6a, you have the functions y equals x, graph y equals x, y equals the square root of x, and we're going to rotate about y equals 1. So let's graph these functions. We have the x-axis, we have the y-axis, we have y equals x. I like to draw the easier functions first. So if you feel like y equals the square root of x is difficult to draw, you can draw y equals x first, and that might help. Okay, so y equals the square root of x looks like that. Okay, so if you have trouble drawing graphs, draw it from the easiest to the hardest. Okay, start with the easier graphs to draw, and then work your way up to the harder ones. However, whatever you think is easier or harder. Alright, so y equals x there, y equals square root of x there. And so now we have two intersection points, and so we see 0, 0. It's an intersection point. And if everything is 1, it works. So 1, 1 is also an intersection point. And so the region between the curves is this shaded region here. We're going to rotate that shaded region about y equals 1. Okay, so about y equals 1. Here's the point 1, 1. So y equals 1 is going to go through that point. So it's important to find intersection points. As soon as you see that there is one, right? The next thing you draw you may need to think about the relationship between the next thing you draw and an intersection point you just found, right? So now that I found this intersection point, when I draw y equals 1, I need to know where that horizontal line is in relation to that intersection point. Is it above it, is it below it, or does it go through it? In this case, it goes through it. All right, so now I'm going to take this shade region, I'm going to rotate about that line, y equals 1. And so to draw the picture of a rotate region, just take the mirror image of this. So the easiest thing about this curve is this line, right? So wait, let me backtrack even further. I'm going to rotate this point. So I'm going to start by rotating points. This point goes here, that point stays where it is because it's on the line. Now I'm going to take this line that connects them and rotate that line and it goes there, the mirror image of it. Then I'm going to take this thing that goes like this and I'm going to, the mirror image looks like that. So now what I just drew one step at a time is the mirror image of that about the line y equals 1. Now I'm just going to take this point and I'm going to rotate it around the line y equals 1 with a circle and get that. Now I probably want to draw another, so actually that's the three-dimensional object, let's say, so you can see it there, right? And so now I'm going to use washers to get the answer. And so now I'm going to draw a washer here. So you have this point, and it rotates around. Right? Now I have this point, rotate it around, and there's a washer. And I have this nice bit of a thickness here. So by just making this line a little wider, I'm going to show that there's a small thickness there. All right, there's our washer. And so because the thickness of the washer is a change in x value, that means that we're going to integrate with respect to x to find the volume. So the volume is a definite integral with respect to x. All right, the leftmost x value is 0. And the rightmost x value is 1 for the shaded region. This is your shaded region. What are the range of x values? It starts from 0, goes from x equals 0 to x equals 1. And so that's the range of x values. Okay? Okay, sorry. All right, I'm keeping check on time. Okay, so now we're going to integrate. And so we're going to use the washer method. Right? So let me just draw a washer over here. Okay. So that's going to correspond with that washer. So we need the smaller radius. Right? We need the little r. Little r, that's up. So this little r is that distance. That distance there, right? Now if you look at this point, this is the y coordinates of a point on this graph. This is x comma y, right? That point is the point x comma y. We're integrating with respect to x. The y value of that point is the square root of x. So the height of that point in terms of x is the square root of x. The height of the center of the circle is 1 because it's on the line y equals 1. And so if the height of this point is the square root of x, and the height and the center has height 1, then the radius is 1 minus the square root of x. 1 minus the square root of x is the length of the radius. So the radius is 1 minus the square root of x. So this, I'm using this part here. I'm just labeling little r and capital R in this picture, right? The capital R here, capital R is like the radius of the bigger circle. And now let's look at a point on the lower curve. Now let's extend this line further to go to this point, which is on the line y equals x. This height is the radius. This length is the radius, right? Now this point is also point x comma y, like I said, and it's a point x comma y on this graph. Now the height of this point, or its y value, is equal to x. So the height of this graph, the height of this point using x is x. That whole thing is 1. So 1 minus x is a larger radius. So the larger radius is 1 minus x. So little r is 1 minus the square root of x. The larger radius is 1 minus x. The area of the entire washer, the area of the entire little r is this part, and capital R is that whole thing, right? The area of the washer, which is the area of the space between the two regions, right? The area of the washer, the volume, has a little bit of thickness there. The volume of the washer is area of the washer. Right? Okay, so forget the thickness. Now here's our washer. The area of the washer is pi times capital R squared minus pi times little r squared. So you just plug in capital R and little r into there. So the vertical, forget, it's just 2 dimensional. Okay, so the vertical cut is a washer, and the area of the washer is a of x here. Okay, so it's a definite integral from 0 to 1 of pi times capital R, which is 1 minus x squared, minus pi times little r, which is 1 minus the square root of x squared. And so it's a definite integral of that difference from 0 to 1. Okay, so you just evaluate it. And so I'm going to move the pi out of it. And then an antiderivative is first 1 minus x, let me expand it first. This is pi times differential from 0 to 1 of 1 minus x squared, which is 1 minus 2x plus x squared, 1 minus x in parentheses squared, minus 1 minus the square root of x squared, which is 1 minus 2 times the square root of x plus x. And so it's that difference integrated from 0 to 1 times pi. All right, so this is equal to the def integral from, this is equal to pi times the def integral from 0 to 1. Combining like terms, 1 minus 1 cancels. 1 minus 1 cancels. There's an x squared here. I'll put the x squared. The x, there's just a minus 2x. Oh no, so there's a minus 2x minus positive x. That's minus 3x. That's the minus 2x minus another x, minus 3x. Minus negative 2 square root of x is plus 2 times the square root of x. X squared minus negative 2 root x. It's plus 2x to 1/2. And so it's equal to pi times the antiderivative of that, which is x cubed over 3 minus 3/2 x squared plus 4/3 x to 3/2, evaluated from 0 to 1. So x cubed over 3 minus 3/2 x squared plus 4/3 x to 3/2, evaluated from 0 to 1. And so I'm going to continue this, I'm going to continue that over here. And say that thing is equal to pi times, plug in a 1/3 minus 3/2 plus 4/3. Okay, so it's equal to pi times that thing. The common denominator is 6. This is 2/6 minus 9/6 plus 8/6. That's 2/6 minus 9/6 plus 8/6. So that's 1/6. So it's pi times 1/6. That's equal to pi over 6. Final answer is pi over 6. All right, and so that's the final answer. Pi over 6 is the volume. That's 6a. So let's continue. Okay. Number 6, find the volume obtained. Oh, okay, we did 6a, sorry. Now we're doing 6b. All right, 6b, you have yeah, okay, 6b. So if y equals x squared, x equals y squared. And I'm going to rotate it about the x-axis. Did I already do this? No, okay. No, okay. About x equals -1. All right, so let's draw the two graphs. And that's x equals y squared. We have the region between the two curves, and so they intersect at the origin and at the point 1, 1. About the line x equals -1. There's the line x equals -1. So I'm going to draw the mirror image of this. So this goes here. This point goes here. this arc goes like this arc will go like that, this arc goes like this arc will go like that. And so that's kind of like the mirror image of that. And you rotate it around, so you rotate that around, and you rotate this around. Right? And so now we have our three-dimensional object. Let's draw a vertical line, because you can think of the area as being swept by vertical lines. And let's rotate the vertical line around the line x equals -1. So we rotate that vertical line about the line x equals -1. Then we get a cylindrical shell. Okay, so we get a cylindrical shell. And so we're just going to think of the entire volume as adding up these cylindrical shells. And so the total volume is equal to the definite integral from x equals 0 to x equals 1. Now the thickness here of the cylindrical shell is a change in x value, so that's how we know we're integrating with respect to x. And so it's a definite integral from x equals 0 to x equals 1 of 2 pi. Now if you look at this point here, that point there, which is on the circle here, the radius of that circle is the x coordinate of that point. And so the radius is x, integrating with respect to x. So 2 pi x times h. The height of the function is the difference in the heights of those two functions. I'll leave a space there. And so this is going to be the top function. I'm just going to write top here because I don't have a lot of space to write here. And then the bottom function, that's the bottom function. All right, so the top function is x equals y squared, and the bottom function is y equals x squared. We want it in terms of x, and so the top function, I'm going to write, instead of x equals y squared, I'm going to write it as or y equals x to the 1/2. All right, and so the y coordinate is the height we want, and it's equal to x to the 1/2, minus the y coordinate of this point, which is equal to x squared. So the top, which is x to the 1/2, minus the bottom, which is x squared. So 2 pi x, that's 2 pi rh. This is equal to 2 pi times definite integral from 0 to 1. Multiplying by x, you get x to 3/2 minus x cubed. dx, this is equal to 2 pi times definite integral. That's multiplying. An antiderivative of that, which is 2/5 x to the 5/2 minus 1/4 x to the 4th. So that's equal to 2 pi times, plugging in a 1, you get 2/5 minus 1/4. And so 2/5 minus 1/4 is 8/20 minus 5/20. That's 3/20 times 2 pi, which is 6 pi over 20. So the final answer is 6 pi over 20. 8 minus 5, 3/20 times 2 pi, 6 pi over 20. All right, and simplify, actually. You can simplify it to 3 pi over 10. That's 6b. C. Y equals x cubed, y equals 8, x equals 0. About the x-axis. So you have y equals x cubed, y equals 8, x equals 0. We're going to rotate the region bounded by those three curves about the x-axis. So y equals x cubed, y equals 8, and x equals 0. Okay, so we have the region bounded by those three curves. Y equals x cubed, y equals 8, x equals 0. So, and now we're going to rotate that about the x-axis. So I'm just going to label these intersection points now. This intersection point is 0, 8. This intersection point, well, when x is 2, y is 8, so that's 2, 8. That's the origin, 0, 0. Now rotate that around, and we're going to get that there. And this point is going to rotate here. That's part of it. This is part of the region, and then that will rotate there. So that's the region rotated about the line, about the x-axis. Now I'm going to rotate it and get that. And you rotate that there also. So you have your three-dimensional region, the rotation of the shade region around. All right, so now we're going to find this volume, and so let's find it using cylindrical shells. Okay, so finding it using cylindrical shells, so we take a vertical line there and we rotate that vertical line. We get this cylindrical shell there in the picture. Right, so the volume is going to equal to differential. Now the thickness of the cylindrical shell is a change in y values. And so that means we're going to integrate with respect to y. And so the smallest y value of the shade region is 0, and the largest y value in the shade region is 8. And so it's going to be 2 pi times the radius. The radius is, if you take this point on the curve, the radius is that length. The length is the y value of that point. So that's the radius, y, times the height. What's the height? The height is the height of this graph, which is y. But the y value, you write this as or x equals, sorry, the height of this is the x value of that point. And so the x value is equal to y to the 1/3. And so the height of, so this length is the x coordinate of y equals x cubed. So solving for x, you get y equals y to 1/3. So the x coordinate is the height, and the x value is y to the 1/3. So we want the x coordinate in terms of y, which is y to the 1/3 dy. So it's 2 pi rh. There we go. This is equal to 2 pi times the differential from 0 to 8 of y times y to 1/3, which is y to the 4/3 dy. And that's equal to, you add 1 to the exponent, you get 7/3, so you get 3/7. So you get 6/7 pi y to the 7/3, evaluate from 0 to 8. This is equal to 6 pi over 7 times 8 to the 7/3 minus 0 to the 7/3. And then, so 8 to the 7/3 is, the cubed root of 8 is 2. 2 to the 7th is 128. So 6 pi over 7 times 128. Okay, so it's 6/7 times 128 pi. So 128 times 6/7 pi. And so 128 times 6. So that's 768. So that's equal to 768 over 7 pi. So the answer is 768 over 7 pi. That's the volume using cylindrical shells. Okay, so now this is 6d. So we're still on number 6, 6d. Y equals the square root of x minus 1, comma y equals 0, comma x equals 5, about y equals 3. Okay, so y equals the square root of x minus 1. It's just a translation to the right by 1 unit of y equals the square root of x. And so y equals, this is y equals the square root of x minus 1. Translation to the right by 1 unit of y equals the square root of x. You have y equals 0, which is the x-axis, and you have x equals 5 here. And so this point, which is 1 comma 0. This point, this is when x equals 5. That's the square root of 4, so you get 2. So this is 5 comma 2. When you plug in x equals 5, you get square root of 5 minus 1, square root of 4, which is 5 comma 2. right? And that point is 5, 0. And we're going to rotate this about the line y equals 3. This point has y coordinate 2, so y equals 3 is above that point. So let's say y equals 3 is here. So I'm going to rotate this region bounded by those 3 curves, which is that shade region. We're going to rotate about y equals 3. And so what we'll end up with is going to continue these out, kind of ignore that there. So I'm going to rotate this here. I'm going to rotate that there, and then I'm going to, that's good, I'm rotate that there. This line connects here to here, it's going to connect there to there, this connects here to here. This is going to go like this, so this is going to go like that. So that's the rotation of the shade region. And then this point gets rotated around like that. This point gets rotated around like that. This point gets rotated around like that, and you get the shade region there. Then, so you have a horizontal line here, and it sweeps around the shade area. And so you get that, and you get that, and then you get this thing. So you take that horizontal line and you rotate it around, and you get that whole thing. Okay, so now we're going to find the volume of that. And so the thickness of the washer is a change in y values. It's a delta y. So we're going to integrate with respect to y. So what's the smallest y value of this shade region? It's y equals 0. And the largest y value is the y value of this point, which is 2. So it goes from 0 to 2. It's cylindrical shells, so it's 2 pi times the radius. The radius of the circle is, this is the center of the circle. And then the radius, the radius is here. So sorry. Wait, this is the center of the circle. This is the radius here. Here's a point on the graph. Now, this point, that's a point x comma y on the graph y equals the square root of x minus 1. That's the radius. That's the height y of that point. Y is so this is the square root of x minus 1 here, that height in terms of x. This whole thing is 3. 3 minus the square root of x minus 1 is the radius. So it's 3 minus the square root of x minus 1. Okay, so again, this is 3. That height is y is equal to the square root of x minus 1. So it's 3 minus the square root of x minus 1 is the radius of the cylindrical shell. So that's 2 pi r h. And now the height of the cylindrical shell, this is, well, this point is x comma y, right? This is the x distance of that point. This is y equals, this is x equals 5, that vertical line. So this whole thing is 5. This is the x distance, so the height is 5 minus x. That's the height, 5 minus x. So you get 5 minus x dx. Wait, sorry, we're integrating with respect to y. This is dy. Sorry. The radius is this. This is y. This is 3 minus y, that's the radius, sorry. 3 minus y, so it's in terms of y. This is the y coordinate, this is the y distance of the point, that's 3. 3 minus y is the radius. 2 pi r h, h is that. And so the x coordinate of this point, it's 5 minus x, right? But what's x? It's on this graph, so, or this is y squared plus 1 equals x, solving for x. If you have y equals the square root of x minus 1, solving for x, you get x equals y squared. Y squared plus 1 equals x. X equals y squared plus 1. So the x coordinate of this point, in terms of y, is y squared plus 1. So it's 5 minus y squared plus 1 is the height. 5 minus y squared plus 1. 5 minus in parentheses y squared plus 1. Don't forget parentheses. 5 minus the x coordinate, which is y squared plus 1. 5 minus in parentheses y squared. So that's 2 pi r h. And so we find this differential. It's 2 pi times the differential from 0 to 2 of this times this. So it's 15. Okay, so this is 5 minus y squared. This is 5 minus y squared minus 1. 5 minus y squared minus 1. 5 minus 1 is 4. This is 4 minus y squared. Okay, that's 4 minus y squared. So we're multiplying 3 times 4, which is 12. Negative y times 4 is minus 4y. 3 times negative y squared is minus 3y squared. And then minus y times minus y squared is plus y cubed. Let's multiply that out. So we're integrating with respect to y. This is equal to 2 pi times an antiderivative, which is 12y minus 2y squared minus 3 minus y cubed plus 1/4 y to the 4th, evaluate from 0 to 2. This is equal to 2 pi times 24 minus 8 plus 4. And that's equal to, that's 16, 8, 12. So 2 pi times 12 is 24 pi. Okay, so you get 24 pi. So the volume is 24 pi. Okay, so number 7. So for number 7, find the average value of the function. So find the average value of the function. For 7a, we have g of x is equal to x squared times the square root of 1 plus x cubed from the interval from 0 to 2. Find this interval from 0 to 2. So the g average is equal to 1 over 2 minus 0 times the definite integral from 0 to 2 of x squared times the square root of 1 plus x cubed dx. Alright, so this is equal to 1/2 the definite integral from 0 to 2 of x squared times the square root of 1 plus x cubed dx. So what's weird here is the 1 plus x cubed and the square root. So we'll let u be that. So we'll let u equal 1 plus x cubed. Du is 3x squared dx. So we have x squared dx, we don't have a 3, so I'm going to have to add that in. So this is equal to 1/2, I'm going to leave space here, times, I'm going to rearrange the terms, the square root of 1 plus x cubed. I have an x squared dx here. So I'm missing is a 3, so I'm going to put a 3 there, so I'm going to multiply the outside by 1/3. And now I can use u substitution, but actually I need the limits of integration also 0 to 2. So using u substitution, first 1/2 times 1/3 is 1/6. The definite integral of the square root of u, 3x squared dx is du. And when x is 0, u is 1. And when x is 2, u is 9. And so this is equal to 1/6. Now remember the square root of u is u to the 1/2. Right? We're integrating u to the 1/2. So the antiderivative is 2/3 u to the 3/2. Right? Antiderivative u to 1/2 is 2/3 u to the 3/2, evaluated from 1 to 9. So this is 1/6 times 2/3 is 1/9. Okay? 2/18 is 1/9. 1/9 times u to the 3/2, 9 to the 3/2 minus 1 to the 3/2. Okay, 9 to 3/2 is the square root of 9, which is 3 cubed, which is 27. 27 minus 1 is 26. 26 over 9 is the answer. All right. There you go. So the average value of g on the finite closed interval from 0 to 2 is 26/9. Okay, so that's 7a. Seven B, f of theta is equal to secant theta tan theta from 0 to pi over 4. Okay, so let's find the average value of f. So the average value of f is equal to 1 over pi over 4 minus 0. Times the definite interval from 0 to pi over 4 of secant theta tan theta d theta. Alright, well, the derivative, I'm going to use theta now. d theta of secant theta is secant theta tan theta. Okay, so an antiderivative of secant theta tan theta is secant theta. So this is 1 over pi over 4 times the definite integral from 0 times an antiderivative of secant theta tan theta, which is secant theta, evaluated from 0 to pi over 4. And so 1 over pi over 4 is 4 over pi, so it's 4 over pi times secant of pi over 4 minus secant of 0. Alright? And so that's equal to 4 over pi times secant of pi over 4 is 1 over cosine of pi over 4 minus secant of 0, which is 1 over cosine 0. And so that's equal to 4 over pi times 1 over cosine of pi over 4, which is 1 over root 2 over 2, minus 1 over cosine of 0, which is minus 1 over 1. Okay, and so that's equal to 4 over pi times 2 over root 2 minus 1. If you rationalize that, multiply this by root 2 over 2, root 2 over root 2, and you get root 2. So this is 4 over pi times root 2 minus 1. You can think like that. Okay, so the answer is 4 over pi times root 2 minus 1. So that's 7b. Good. Everything's good. So next we're going to go to number 8. Alright, so for number 8, find the inverse of the function. So A is the function is f of x is equal to 3 minus 2x. Find the inverse of that function. So I'm going to write y equals 3 minus 2x. And so I'm going to solve for x explicitly in terms of y. So you get 2x is equal to 3 minus y. Divide by 2. X equals 3 minus y over 2. Now I solve for x explicitly in terms of y. Y, switch x and y. Y, which is now f inverse of x, is equal to 3 minus x over 2. We now found the inverse function in part A. For part B of number 8, find the inverse of the function. Our given function is f of x is equal to 2x cubed plus 3. And so I'm going to use y instead of x. So y equals 2x cubed plus 3. Now I'm going to solve for x explicitly in terms of y. Y minus 3 is equal to 2x cubed. Y minus 3 over 2 is equal to x cubed. Take the cube root of both sides. X is equal to y minus 3 over 2 to the 1/3. switch x and y. Y, which is f inverse of x, is equal to x minus 3 over 2 to the 1/3. That is f inverse of x for part B. All right, so that's 8a and 8b. Maybe I can put 8c down here. So for 8c, we want to find the inverse of y equals ln of x plus 3. So I'm going to take e to both sides. E to the y is equal to e to the ln of x plus 3. E and ln cancel, so that equals x plus 3. Solving for x, you get x equals to e to the y minus 3. Switching x and y, you get y equals e to the x minus 3. And so in this case, f inverse of x is e to the x minus 3. And that's the answer for part C. And so I split the board into 3 sections. This is for 8a, this is for 8b, that's for 8c. All right, so that's number 8. All right, so find the inverse of the function. Those are 3 examples. Okay, so that's page 1. That's the end of page 1. So now we're going to go to page 2. And so for page 2, number 9 is differentiate the function. So part A of number 9, differentiate the function. We've given f of x, the function is equal to log base 2 of 1 minus 3x. So we're going to use the formula d dx of log base a of x is equal to 1 over x ln a. Okay, so d dx of log base a of x is equal to 1 over x ln a. So here, the derivative of that function, f prime of x, is equal to 1 over, instead of x, we're going to combine this with the chain rule. So d dx of log base a of u, where u is a function of x, is 1 over u ln a times du dx. This is combining that equation with the chain rule. So d dx of log base a of u of x is equal to 1 over u of x times ln a times du dx. And so you just plug that in here. So with this formula, it's easy. So f prime of x is equal to the derivative of that, which is 1 over, this is u. Okay, that's u, 1 minus 3x. Right, that's 1 minus 3x is u. So this is 1 over u, which is 1 minus 3x, times ln of a. Here a is 2. That's a. Times ln of 2, times du dx, times the derivative, times d dx of 1 minus 3x. So again, it's 1 over u ln of 2 times the derivative of u times the derivative of 1 minus 3x. So that's equal 1 over 1 minus 3x times ln 2 times the derivative of 1 minus 3x, which is negative 3. And that's the answer. So that prime of x is equal to 1 over 1 minus 3 times ln of 2 times negative 3. That's 9a. All right. 9b. Again, differentiate the function. The given function is g of x is equal to ln of a minus x over a plus x. And so we're going to find the derivative. Okay, so instead of log base a, it's just ln. So now d dx first d dx of ln x is 1 over x. Applying the chain rule to that equation, d dx of ln of u, a function of x, is equal to 1 over u times du dx. So we're going to be using this equation here. So that equation combined with the chain rule. So g prime of x is going to equal, well, u is going to be this fraction. U is a minus x over a plus x. So g prime of x is 1 over that fraction, a minus x over a plus x, times the derivative of u, times the derivative of a minus x over a plus x. And so this is equal to, 1 over a fraction is its reciprocal. So 1 over a minus x over a plus x is a plus x over a minus x. times now the derivative of that fraction, which is just the quotient rule. So it's the bottom function, a plus x, times the derivative of the top function, which is minus 1, minus the top function, a minus x, times the derivative of the bottom function, which is 1, over the bottom function, a plus x squared. And that's the derivative of a minus x over a plus x. So g prime of x is that fraction times that. And that's the answer. You don't have to simplify. All right? That's g prime of x. When you find a derivative, you can find it without simplifying. If you need to use a derivative later on, you may need to simplify it to use it. If you're not using the derivative, if you're just finding it, you can just write it. All right? So that's 9b. Okay, so that's 9b, differentiates the function. So let's go to 9c. So differentiate the function. So 9c is y equals e to the ax cubed. Okay, so we're going to differentiate, we're going to find y prime. So let's, first we have the equation d dx of e to the x is equal to e to the x. Combine that with the chain rule, we get d dx equals e to the u. d dx of e to the u is e to the u times du dx. Okay, so d dx of e to the u is e to the u times du dx. Here, u is going to be 9x cubed. Ax cubed. Here, u is ax cubed. It's an a. So y prime, the derivative of e to the u, is e to the u, e to the ax cubed, times the derivative of u, times the derivative, d dx, of ax cubed. All right? And so this is just equal to e to the ax cubed times the derivative of ax cubed, which is 3ax squared. And that's the answer. So y prime is e to the ax cubed times 3ax squared. It's y prime, so we differentiated y. That's 9c. Wait, 9d might use some space, so I'm going to have to erase this for 9d. Okay, so 9d, y is equal to 2x plus 1 to the 5th times x to the 4th minus 3 to the 6th. Okay, so we're going to use logarithmic differentiation. Take ln on both sides. Okay, so the first function is 2x plus 1 to the 5th, and the second function is x to the 4th minus 3 to the 6th. And so it's ln of a product of two functions. That's the sum of the ln's of those functions. So ln of 2x plus 1 to the 5th plus ln of x to the 4th minus 3 to the 6th. Okay, and so that's by the first law of logarithms. Equals, now by the third law of logarithms, you move the exponents in front. That's 5 ln of 2x plus 1 plus 6 times ln of x to the 4th minus 3. Okay, and so now I just move the exponents in front by the third law of logarithms. So what I have now is ln of y is equal to that. That's step 1 of logarithmic differentiation. Step 1 is take ln of both sides and expand using the laws of logarithms. Step 1. Ln of both sides, and then expand using the laws of logarithms as much as possible. That's step 1. Step 2, differentiate implicitly with respect to x on both sides. So left side, d dx of the left side is 1 over y times y prime. dx of the right side is 5 times 1 over 2x plus 1 times the derivative of 2x plus 1, which is 2, plus 6 times d dx of ln of something, which is 1 over that something, times the derivative of that something, which is 4x cubed. So now I differentiate it implicitly with respect to x. That's step 2. Okay, so that's the end of step 2. And now I'm going to solve for y prime for step 3. And so to solve for y prime, you just multiply both sides by y. Y is that. So you're multiplying both sides by 2x plus 1 to the 5th times x to the 4th minus 3 to the 6th power. And so the 1 over y times y cancels. You get y times that on the right side. 5 times 2 is 10. 10 over 2x plus 1 plus 6, 12, 18, 24. 24x cubed over x to the 4th plus 3. Okay, and that's step 3. Oh, so this is a minus 3 here. That should be a minus sign. Oh, that's a minus sign. Good. So that's y prime. We differentiate y. All right, so that's 9d. Let's go to 9e. Differentiate the function y equals sine inverse of 2x plus y. Okay, so the derivative of y prime is, well, first we're going to use the function d dx. First, d dx sine inverse x, right, is 1 over the square root of x squared minus 1. We're going to combine this with the chaining. So d dx of sine inverse u, where u is a function of x, is 1 over the square root of u squared minus 1 times du dx. And so we're going to use this equation here. We're going to combine the derivative of sine inverse with the chaining rule. All right, so using that, we have u. What is u? U is 2x plus 1. And so y prime is 1 over the square root of u squared, which is 2x plus 1 squared minus 1 times the derivative of u, which is just 2. So we get y prime is equal to 1 over the square root of 2x plus 1 squared minus 1 times 2. That's the answer to E. All right. Okay, so that's 9E. Hold on 1 second. All right, let's keep going. Number 10. So number 10, find an equation of the tangent line to the curve at the given point. So it's y equals ln of x cubed minus 7. The point is 2, 0. All right, so in order to know the equation of a line, if we know its slope, and we know a point, and here our point is 2, 0. If we know those two things, the equation of the line is y minus y1 equals m times x minus x1, where this is x1, comma, y1. So x1 is 2, y1 is 0. If we know the slope of the tangent line, then combined with the slope and a point that's given to us, we can just plug in, and we have y minus y1, which is 0, equals m times x minus x1, which is 2. So we just need to find the slope of the tangent line and plug it in there, and we're done. Okay, so it's a slope of a tangent line to this graph at that point, meaning the goal is to find the derivative of that function at x equals 2, and that equals the slope of the tangent line at that point. So the slope of the tangent line to this graph at that point is y prime of 2. We're going to find that and just plug it in there. Then plug in m2 y equals m times x minus 2, because it's y minus 0 there. Okay, so that's the goal, because I'm including this stuff in, all right? So y prime of x, which is the derivative of that function, is 1 over x cubed minus 7 times the derivative of x cubed minus 7, which is 3x squared. Y prime of 2 is equal to 1 over 2 cubed minus 7 times 3 times 2 squared. And so that's equal to 3 times 2 squared is 3 times 4, which is 12. 12 over 2 cubed minus 7 is 8 minus 7, which is 1. 12 over 1 is 12. So m, which is y prime of 2, is 12. The slope is 12. And so you just plug that in. And so our tangent line has the equation y equals 12 times x minus 2. You could also write it as y equals 12x minus 24. And there you go. I'll write it like that. So the equation of the tangent line to that graph at the point 2, 0 is y equals 12x minus 24. And so we're done with that problem. All right. Okay, so that's number 10. Okay, so number 11. Find the length of the curve. So for A, we have y squared equals 4 times x plus 4 cubed. And it's from 0 less than or equal to x less than or equal to 2, y positive. All right? So we're going to use the formula. We have a range of x values here, so let's use x. We have L, the length is definite interval from 0 to 2 of the square root of 1 plus dy dx squared dx. So we want to find dy dx, plug it in to there, and calculate the definite interval. So if y squared is that, and that means y is the square root of the right side. So that's 2 times x plus 4 to the 3/2. That just took the square root of y, which y squared, which is y, times the square root of that, which is the square root of 4, which is 2, times the square root of x plus 4 to the 3, which is x squared to the 3/2. All right? That's y. So now dy dx is equal to the derivative of that with respect to x. And so you get 2 times 3/2 x plus 4 to the 1/2, 3/2 minus 1 is 1/2, times the derivative of x plus 4, which is 1. So dy dx is equal to 2 times 3/2, which is 3, which is 3 times x plus 4 to the 1/2. dy dx is 3 times x plus 4 to the 1/2. dy dx squared plus 1 is equal to 1 plus that squared, which is 9 times 3 squared is 9. X plus 4 to the 1/2 squared is x plus 4. So that's equal to 9x plus 36 plus 1 plus 37. 1 plus dy dx squared is 9x plus 37. Good. Okay, so this is equal to the definite interval from 0 to 2 of the square root of 9x plus 37 dx. And so what's weird about this is the 9x plus 37 in the square root. So we're going to do substitution. We're going to let u equal 9x plus 37. So du is 9 dx. So we're missing a 9 here. So we'll fix that. And so we'll leave space here. So definite from 0 to 2 with the square root of 9x plus 37. And then the dx is here. You need a 9 in front, so a 9 dx. And then multiply the outside by 1/9. And so this is equal to 1/9 times the definite integral of the square root of u, that's u to the 1/2, 9 dx, which is du. Evaluate from when x is 0, u is 37. When x is 2, you get 18 plus 37, which is 40, which is 55. Zeros for the other differential. Okay, and so we're going to calculate this definite integral, and then we're done. And so this is equal to 1/9 times the antiderivative u to the 1/2 is 2/3 u to the 3/2. valued from 37 to 55. So I'm going to continue that. This is the side work here. I'm going to continue that over here. Okay? So this is going to be equal to star. So star over here. And that's equal to 1/9 times 2/3, which is 2/27, times u to 3/2 value from 37 to 55. So that's 55 to the 3/2 minus 37 to the 3/2. Okay, and so that is the answer. That is the length of that curve from x equals 0 to x equals 2, y positive. 2/27 times 55 to the 3/2 minus 37 to the 3/2. That's 11a. Alright, so let's skip 11b. It's another arc length problem. And then let's go to 12. So number 12, find the solution of the differential equation that satisfies the given initial condition. So for 12a, we have dy dx is equal to y squared plus 1, where y of 1 is equal to 0. And so I'm just going to move the y's to the left side and the x's to the right side. So you get 1 over y squared plus 1 dy is equal to dx. Integrate both sides. This is the same as the integral of 1 over 1 plus y squared dy is equal to the integral of 1 dx. Well, the integral of this is tan y. Tan y is equal to x plus c. That's the answer. And we solve for that, so we solve for that implicitly in terms of, we solve for y implicitly in terms of x. Now I'm going to plug in y is 0, x is 1. So if y is 0, and x is 1, we have tan of 0 equals 1 plus c. Tan of 0 is sine 0 over cosine 0, that's 0. 0 equals 1 plus c, that means c equals -1. So if c is -1, we plug that into that equation, and the final answer is tan x equals x minus 1. Tan y is equal to x minus 1. Now we solve implicitly for y in terms of x. We solve for y implicitly in terms of x. Okay, if you want to solve for y explicitly, you could say y is equal to tan inverse of x minus 1. Right, so that is the solution to this initial value problem. Solve for y explicitly in terms of x. Y equals tan inverse of x minus 1. That's 12a. So that's 12a. Alright, so 12b. So for 12b, we're going to the same problem. Find solution of differential equation satisfies the given initial condition. X cosine x is equal to 2y plus e to the 3y times y prime, where y of 0 equals 0. Alright, so now we're going to move the y's on one side. Well, actually, first I'm going to write using Leibniz notation. X cosine x equals 2y plus e to the 3y times dy dx. I'm going to move the x's on one side and keep the y's on the other side. So this is x cosine x dx is equal to 2y plus e to the 3y dy. Now we integrate both sides. So that integral equals that integral. And so, okay, so what I'm seeing now is that this, that I haven't told you how to do this integral. So, okay, so I'm going to, you're not going to see 12b on the review sheet. Okay, so when you watch this video, 12b will not be on the sheet. Okay, so just forget about this part. All right, 12b is that. You never saw it, don't worry about it. All right, 12b. All right, so now 13. So for number 13, a bacteria culture starts with 500 bacteria and grows at a rate proportional to its size. After 3 hours, there are 800 bacteria. Okay, so the bacteria, let P of T be the population of bacteria after T hours. Okay, so P of T is the population of bacteria after T hours. dPdt is the growth rate. And so since the growth rate, dPdt, is proportional to its size. So we know dPdt equals Kp. So we know the form of the solutions of that differential equation are P of T equals P of 0 e to the Kt. So all solutions look like that. P of T equals P of 0 e to the Kt. It starts with 500 bacteria. That means P of 0 is equal to 500 bacteria. Okay? And after 3 hours, there are 8,000. So P of 3 is equal to 8,000. So P of T is equal to P of 0, which is 500 e to the Kt. We want to find an expression for P of T, the number of bacteria after T hours. So let's plug in P of 3. P of 3, which is 8,000, is equal to 500 e to the 3k. Let's solve for k. 8,000 divided by 500 is equal to 16. Okay. The 2 zeros go away. 80 over 5 is 16. 16 is equal to e to the 3k. Take ln of both sides. Ln of 16 is equal to ln of 3 to the e to the 3k, which is 3k. K is equal to ln of 16 over 3. That's k. And so P of T is that. And so just plug in k there. So P of T is equal to 500 e to the ln 16 over 3 t. Okay, so that's P of T. You could also think of this as 500 times e to the ln of 16 to the 1/3 t. 16 to the 1/3 t as an exponent. 16 to the t over 3. Okay, because then the t over 3 as an exponent of 16 could move to the front. And you get that. Okay. Well, then the e and the ln cancel, so you get 500 times 16 to the t over 3. So P of T equals 500 times 16 raised to the t over 3. So that's the population after T hours. So write that out. P of T is equal to 500 times 16 raised to the t over 3. That is the population of bacteria after T hours. So that's the answer to part A. Part B is you just plug in 4. With the number of bacteria after 4 hours, it's just P of 4. And so you just plug that in. That's 500 times 16 to the 4/3. Alright, and so you calculate that. That's P of 4. Okay, and the rate of growth after 4 hours. Well, the rate of growth after 4 hours, dPdt is equal to Kp. So the growth rate after 4 hours is the growth rate when t is 4. So that's k times p of 4. So that equals k, which we found was ln of 16 over 3 times p of 4, which is that, times 500 times 16 to the 4/3. And you can plug that in your calculator and you get the answer. Next, that's C. Almost done. So it's A, B, and C. And then for D, when will the population reach 30,000? Okay, so that's A, B, and C. So I only need the answer to part A and part D. So I'm going to erase everything else. That was our answer for part A. And so for part D, when will the population reach 30,000? So just set P of T, which is 500 times E, 500 times 16 to the T over 3, set that equal to 30,000 and solve for T. Okay, so So solve for t. Find the value of t you plug in there so that the population is 30,000. So divide both sides by 500. You get 16 to the t over 3 is equal to 30,000 divided by 500, and you get 60. And take ln of both sides. So you get ln of 16 raised to t over 3 is equal to ln of 60. Exponent goes in front. T over 3 is equal to ln of 16, which equals ln of 60. And so now t over 3 is equal to ln of 60 over ln of 16. Multiply both sides by 3. You get t is equal to 3 ln of 60 over ln of 16. That's the final answer. So that's how many hours it will take for the bacteria to reach a population of 30,000. All right, and so we're done with going over the review sheet. All right, so I hope this review sheet and going over the answers helps you prepare. All right, good luck.